So today's webinar is dedicated to machine learning. We will review a couple of capabilities that are currently present with bpm'online. We will try to build a model to predict, and we will actually try to predict some values based on our inputs. We'll show you what we can do at this point and what we probably be able to do in the future. I'll tell you a little bit about what's coming in the pipeline in the next version or the version after. Today's webinar is the first time I'm conducting something on the machine learning, so I'm not sure how much interest it will generate from the people. So we're going to try to keep it maybe not as very, well, technical, but not very, very technical. We're not going to go into every single detail, but technical enough so that you can build your own model and hopefully try to play around. If you have any questions, you can ask me in the chat box right now. I'm going to ask you that you don't unmute yourself. I'm gonna try to answer as many questions as I can from the chat. If you have any follow-up questions later on, feel free to email me. You should probably have my email by now. And if you have recommendations for future webinar, or you have some areas that you would like me to cover, maybe a different data set, maybe a different type of problem, I'd be happy to do a version 2.0 of this webinar. And hopefully it's going to be a little bit better and a little bit more applicable to what you would like to see or how you would like to use this functionality. Okay, so let's dive in. I'm going to be demoing on my local host, so you can see it's my local host. Everything is installed locally. It makes it a lot easier to debug things. And I am using version 7.12.1.924. Now, yesterday we released version 7.12.2, 891. I think it's a release candidate. So there were a couple of fixes and a couple of major improvements in the new release. So feel free to get a trial, get a demo, and give it a go. Pretty cool release. Okay, so let's dive right in. Machine learning is the element that was added, I believe, 2 or 3 releases ago, so it's been around for probably 6 months, but I think it's one of the most underutilized functionality in the system right now. So when you are logging on to your instance, you will find it under Studio, and you will see ML models. So this is where machine learning models are defined by default. If you're playing with the standard sandbox, then you're going to have machine learning for things like case predictions, lead scoring, or lead qualification, things of that nature, right? So you're going to have a couple of models already there. Now, a few things to know about the models. The models need to follow a certain workflow. So first, we need to train them, and then we can use them to predict some values. Now, the models, when we train them, we usually train them on the data that we obtained from bpm'online itself. So to do that, we're going to have to compose some sort of a statement or some sort of a procedure that will get the data, and it will submit to the machine learning server that runs in the cloud. That server will do whatever it needs to do. It will try to solve statistical problems and come up with the model. That model will then be saved for your instance, and every time you are trying to score something or predict some sort of a value, you will be talking to the server. So the thing to remember here is that you're not downloading a graph, inference graph of any kind down to your instance of the machine. Everything is in the cloud. It's accessible by your APIs. And when you have that key generated to yourself, then that's when you can start using them. Now, a couple of admin things to go over. The model that we're going to be using, or the current capability of the functionality, is basically limited to 75,000 records. So you cannot have a model that we are going to be training on more than 75,000 records at a time. It's too big. Maybe in the future we will up that number, but as of this point, 75,000 records is the maximum that you can do. Also, in terms of licensing and in terms of normal use, we are allowing 100,000 requests per month. Now, the requests that you're making to the cloud machine learning server, Yes, so the video is recorded. Sorry, if somebody missed that. So in terms of licenses, 100,000 requests. So what's considered a request? So let's assume that we have a model of some sort. The model is predicting some sort of a value. It may be a classification, or maybe it's returning a probability of success for something. If we're making a request for one row, that's going to be considered as one request. We can also make a batch request, and the batch can contain up to 5,000 data points inside. So technically, it's like predicting 5,000 problems at the same time. It's still going to be considered as one request. So the difference is how we're formulating the request. Now, the reason behind it is simply the amount of resources that's required when you're making one request versus when you're making a batch request. Um, the biggest resource is going to be spent in terms of generating the request itself. So to give you an example, if, for example, you were making a request to a prediction server with one record, it's going to return you the answer within 1 second. If you're going to make the same request with 5,000 records in batch, it may return you 5,000 answers in 3 to 5 seconds. So it's not linear. That's why we're limiting the amount of requests. What you're putting in the request is really up to you. Now, it's unlikely that you're going to have that much data to begin with, so it's probably not going to be a big deal. So what I've done so far is I've created a little, I've created a section in bpm'online, and I put it in ML demo workplace, so the ML bank client, and I've downloaded the data from publicly available data from a data set. It contains about 45,000 records, and the data is basically telling me information about success or failure of somebody purchasing a term deposit with the bank. So it's looking at some data. It's looking at the duration of, let's say, the duration of the conversation. It's looking at the age of the person. It's looking at whether or not the person has been contacted in the past, etc., etc. I will attach all the information all the data that I used in the notes, in the follow-up notes to the same. I'll post it somewhere on probably Google Drive so that you can download it in case you're interested, as well as the package that implements this functionality. So let's take a look at where I've gotten it. Let me just open this file for us. And let's take a look at the data. Just 1 second, I'll find this. Okay, bank. Okay, so this is what I downloaded from the bank, not from the bank, from the intranet. So it's the model. It came in a zip archive with some stuff in it. So the stuff that we gotten is basically two CSV files and the description. The CSV file contain the information. So there's two. The files are conveniently broken down for us. One has about 4,000 records. That's for our testing the model. So you can see that it's got 4,500 records. And the second file is to train the model, and it's got about 40-some thousand records. I don't remember exactly how many. So it's got 45,000 records. So one file is presumed to train the model. The other one is to evaluate the quality of our model. Now, we don't really need to do that because some of that stuff and some of this complexity is taken away from us, and the algorithm that is implemented already takes care of this pipeline, so we don't really need to break the data down. It's going to be done automatically for us, so we can use just one file. It's big enough to understand the concept. Now, in a text file that came along with the attachment, it's telling us where the file came from, the research, and most importantly, it's telling us the description of the fields that's available. So it's telling us a little bit of information about the person in reference to whom we're trying to make a decision. So it's going to have an age. It's going to be a numeric value. We're going to know something about the job, marital status, so married, divorced, widow, etc. We're going to know the education. So it's going to be unknown, secondary, primary, tertiary. The balance that the person carries on the bank account, whether or not person has a housing loan, whether or not they have a personal loan, how we've contacted the person by cell phone, by regular phone, or we don't know how we contacted them. The day number, or basically the numeric value for the day when we contacted. So if it's September 5th, then the value in this field is going to be 5. The month is going to be the actual month. The duration of our conversation in seconds. And the other attributes is whether or not there was a campaign, number of days since the last campaign, previous outcome, and previous number of contacts. And then what we're trying to do is we're trying to forecast whether or not the person is going to subscribe to a term deposit. And the answer that we're expecting is binary solution, yes or no. Binary, only 2 choices. Now, the data that I've obtained is convenient. It's easy to work with. It's not too complicated. But what you would probably want to do is you would probably want to use the data that you already have in bpm'online in one way or the other. And it's certainly possible. It just, I do not have a data set that contains enough records to train the model, which brings me to problem number 1 with the machine learning. Machine learning requires, it's a good practice to start playing with especially classification problems where we have the amount of records 3 times the amount of features that we're using to describe the record. Now let's talk about what's a feature and what's the record. So let's imagine that you have that we're trying to describe a person. If we have an age, that's going to be 1 feature. Now the age, it's a numeric value, so it's going to be a numeric feature. Let's say we have another property to describe the person, for example, a job. In this particular case, the jobs are categories, so they're already classified for us. It could be admin, it could be unknown, unemployed, management, etc., etc. Every value in this possible job selection is going to be a feature. So we have to add them up. So 1, 2, 3, whatever, 7 or 8 features here. Marital status, we have 5 here. And education, etc., etc. For every feature, we want at least the minimum is 3 times the records. And again, depending on the complexity and how well the data correlates to the feature, you may need more of that. So a good model is when you have probably a couple of thousand records, then when you can start really seeing some, finding some relationships and positive correlations between the data and the outcome. Otherwise, your model may just simply come back with the very poor prediction value, or it's going to be a low quality model. So if you try to train this thing on maybe 100 or 200 records, the variation in data is too great to find similarities and to be able to cluster things so we can make some reasonable predictions. So the more data you have, the better off you are. Now, when we're talking about more data, sometimes what happens is that we're trying to, there's a concept of overfitting. And what that means is that our model is going to be influenced exclusively by our experiences. So we're giving the algorithm the history of our interactions, so they're positive, negative, whatever they are, and then we give it a bunch of other properties. So the experiences are ours. The properties that describe our experiences, they're just ours, right? So we can't really train the model on one data set and then reapply it to somebody else. And that answers the question why we do not have pre-built models for various organizations that might be standard. Well, the simplest answer is that everybody treats things differently, and that's why there is absolutely no point trying to pre-build something and then retrain the model. It's counterproductive. The models that support that type of a pre-trained, like neural networks, we do not yet support. It's coming in the future, but not yet. So every model that you build, you'll have to train from the beginning. It's going to be your model and your model only. And then we're going to be using the values that we're going to be using our model to predict based on the new values. So that brings us to a second very important concept, is the consistency of record keeping. If, for example, we are using one of the columns that is arbitrary, it's not a numeric, it's not age, weight, height, or length, right? And it's a numeric. Let's say, rate your experience on a scale of 1 to 5. Well, somebody can say that my experience was 5. Same experience, somebody might say that it's only 3. Now, this is arbitrary data, so it's going to be difficult for us to say that, we've provided the same quality of information. So it's important to have metrics that are of a good quality. So something that we can verify, something that we can repeat. Also, the metrics, if they're found to be important, if they're significant for our model, they have to be present in order to make good forecasts. So let's assume that, for example, we don't know yet, we haven't trained this model. So let's assume that the age is going to be a very important factor. It's very significant in making a prediction whether or not somebody is going to subscribe to a term deposit. So if the age is missing, um, then we probably will not be able to make as good of a decision as we could had the age been present. So again, it's very important for us to have all the data and make it consistent. So in today's training, we're going to take away all those difficulties because we're working with the data set that's nice and clean. We don't have to do any pre-processing. We don't have to fill the values. We're just simply going to take the data. Let's talk a little bit about the features and how we select the features. So the features, when we're selecting them, we also want them not to be describing the same property. So let's assume that we're talking about a duration of our last interaction. It's number 12 here on the list. And it says that it's expressed in seconds, numeric value. Let's assume that we wanted to enrich our model, and let's assume that when we train, we get some sort of a metric that's telling us how good the model or how bad the model is, how well it's going to perform. And let's say the result that we're getting is not something that we're happy with. Let's say maybe it's only 60% chance that it's going to get it right. We want to improve the quality. Well, the more metrics we have, or the more features we have, probably the better our model is going to be. Well, let's assume that we're going to throw another feature here, and we're going to say that now let's express the duration of conversation not in seconds, but in minutes. Well, it's the same thing. It's the same data. They're perfectly correlated metrics, meaning if one goes up, the other goes up. So it's not going to be a good feature. It's only one time that you want to add that property, right? So that's important. Also, let's imagine that we are trying to score a model based on some sort of a distance. Let's say we want to predict how long it's going to take for our package to get to the final destination. If we throw a distance between the origin point and destination point, that's probably going to be a pretty good metric for us to apply to our model. However, on the other hand, if we're going to describe the coordinates, the latitude and longitude of the destination and the origin, it's probably not going to be as good of a feature. So feature selection from your data is going to be very, very important. It's more of a art than science. I mean, there's quite a lot of algorithms that can help us evaluate how good our feature is doing. Unfortunately, in this iteration of the release, we don't give you those tools, but in the next version, you will be able to see how well your feature is performing, whether or not it's significant, how significant it is, how it correlates, and what's going to happen to your model when you miss that feature, etc., etc. All right, so we talked a little bit about the features, about the data. Now let's talk about problems that we can solve as part of this tool. There are two general problems that we can solve right now, that we can address. And the first one is going to be the classification, and the second one is going to be scoring. So classification problem is something that allows us to make a classification decision. So for example, whether or not someone's going to buy a term deposit, just like the data here, it's going to be a typical classification. Classify the answer into two classes, yes or no. So it's a binary classification. Similar type of problem could be, let's assume that we are getting a new case, we're getting it by email, and we want to figure out what kind of SLA we want to apply or what kind of a service request that is. Let's say we have 5 to choose from. That's going to be classification. So when we have a predetermined list of things to choose from, then this is a classification problem. So for example, shall it be a corporate sale or shall it be a small to medium-sized business sale? That's going to be a classification problem. On the other hand, we have another model or another algorithm that's running in the back end that can solve a probability problem or scoring. So let's rephrase our question in terms of whether or not somebody is going to buy a term deposit and say, what is the probability that someone is going to buy it? So for example, the answer is going to be, the probability is going to be expressed in percent. So let's say the probability is 60%, while our model gives us the answer, and that's a scoring, right? So it's telling us the chances of someone buying it is 60%. Now, is that a yes or no? I don't know. It depends on you. It depends on your interpretation of what this probability is. All we're doing is, given the amount of observable data, something that we observed when we train the model, we are predicting with a certain level of confidence that the answer is yes, and it's, let's say, 65%. Now, some people will say, okay, as long as it's greater than 50, it's a coin toss. If it's greater than 50, it's a yes. If it's less than 50, it's a no. It's okay to do that, but it's probably a little dangerous. You probably want to have a little more, you probably want to have a little different brackets, basically, to decide. So maybe you'll say that if the probability is, let's say, 75 and higher, okay, it's a yes. If probability is, let's say, 40 and lower, it's definitely a no. And everything between 40 and 75, it's a maybe. I don't know what to do with that. So maybe I need to look at it by hand, or whatever your workflow, whatever your pipeline is. So it's very important that we understand how we interpret the data. So the machine learning is only going to give us, at this point, two answers. It's going to give us either classification, yes or no, or it's going to give us a probability. Now, a couple of other models that are going to be introduced in the near future is regression. So it's something that's going to allow us to predict a numeric value given set parameters. So a typical statistical problem is going to be predict a selling price of a house given number of bedrooms, square feet, etc., some other properties describing the house. That's going to be a classification problem. We don't have it yet, so there's no need. Going into details there. So let's go into our machine learning section here, and let's see how we can configure it. So first, let me show you what I've done so far. So I basically went through Section Wizard, and I've created a new section. I called it ML Bank Client, and that's simply how the data set is called. Let's open one. In this model, we're going to have two values. So desired target, that's straight from our data set, and that's going to be either yes or no. That's a value that we're trying to predict. And then the second type of model, so this one is going to be giving us the answer when we're trying to use the classification problem. And this one is when we're going to be using a scoring model. So those two models, they can work together, but it's probably counterproductive. So it's better if you only have one model. I mean, I've never tested using one model against the other. Now here I am simply populating the values that I'm obtained. Well, not the values, but simply here it's a visual representation of what the values are from that file. I then took that Excel file and I imported that into the system. 45,000 records, took me like 20 minutes to import, and then I got my 45,000 records. So far so good. We've done absolutely nothing, and you probably know how to do that. Okay, so next what we want to do is I wanted to actually build a model that will take this thing, or take the information from this part of the screen, export the entire 45,000 records, give it to the server, ask the server to train the model, do something, and then tell me, okay, I'm done, so I can actually go ahead and score it. Okay, so let's go into the ML models. I've created two. One is going to be bank term deposit purchase, that's classification, and the second one is going to be scoring. Very similar models, it just they are the different type, just like you have activities of different type, we have to define it from get-go. Let's open the first one. This is our classification problem. So what it starts from, when the model is trained, it's going to give you the expected accuracy. So currently, the way our algorithm works on this particular model with the data that I've selected, it's expecting to give me 87% accuracy of my model. So basically, out of 100 questions that I ask, the system will be successful at answering 87 times. So 87 times it's going to get the answer right, and 13 times it's going to get the answer wrong. So that's kind of the idea. We don't know which wrong it's going to be, if it's going to be a false positive, or if it's going to be a false negative, or whichever one it's going to be. We don't know, but we know that 87 times out of 100 is going to get the right answer. Now, how does it know that 87 times? It knows it because we've uploaded 45,000 data, 45,000 rows, and those 45,000 rows, the system in the backend split it into 80-20 ratio. So it took 80% to train the model, to observe the behavior of the data, and then it used 20% to evaluate how it's doing. So it's 80-20 typical split. Once the model is trained, like that's basically the result. That's how we get the answer. Now, a couple of properties that we can describe here. First is the type of prediction that we're going to be making. So lookup prediction, other words, classification. So we're making a prediction for a value in the lookup field. So clearly the values have to exist first. Then we have to define which object we're going to be doing it on. So I've created my section. When I created my section, I called the object ML demo bank client. So that's simply the name of my section. In step number 2, and let's review step number 2 right away because it's the easiest one. It's going to be retrain model after 30 days and quality metric lowest limit. So this lowest limit, 0.8, refers to this expected accuracy. So had I trained my model and my result was 79, the model wouldn't be used in any kind of prediction. And that's simply because I said that I want to get at least 8 out of 10 right. Now, if the result of my data after training is less than 0.8, then I'm simply going to ignore this model, and I'm going to consider it as a bad model. It's not going to be used in any predictions or any forecasts. History tab will tell us about things that were happening with the model. So I've been trying to play with this, and you could see that I played with this 45,000 sample data I uploaded just to kind of see what's going on here. The idea here is that you can see what's going on. So the error is unable to connect to the remote server. I forgot to plug my laptop into the internet. And then a couple of training sections. So I was training this particular data set. You could see that I trained it in 45,000 record and only on 4,000 records. So I was training things a little differently. All right. Now, the most important thing, model settings. Here, in this one, training set query. This is the query that will allow us to get the data out of the system. So it's formulated in this particular way. And this is the data that's going to be submitted to our machine learning server that lives in the cloud. You don't need to worry about where it is and what it's doing and how to get a hold of it. Once you formulate this thing, it will simply work. If you write this thing and it's wrong, and for example, for some reason you're getting an error, it's simply not going to do anything. So it's going to know that there was an error, and it's either going to default back to the last trained model, or it's going to say, well, I was unable to train, so nothing's going to happen. In this one, in this box, we're describing what we're querying here. So for example, I have to describe what this is, what this age thing is. So I have a column in the table called ACDM ML Bank Client. So that's the object where I'm storing everything, right? And I'm saying that by the way, if you're familiar with SQL script, then it's going to be no problem for you at all to compose this thing. And for those who's not familiar, you can follow the examples. I'll provide you a couple of very useful links where you can read more information. It's all in Academy for now. Okay, so it starts off by providing this user connection. We don't need to worry about it. What that does, we just have to have it. And then we're doing this dot column and then 2 parameters. The first one is going to be the table name, and the second one is going to be the column that I'm querying. Now, I'm not doing any crazy queries where I'm doing nested tables. Everything is basically nice and easy. Everything is stored in a very flat format. So I'm not saying that let's go to an account and let's grab 10 activities from the account and calculate the duration of every activity, and let's calculate moving average, and then let's use that number. You can certainly do that. It just complicates this query, and I think that it's a little bit unnecessary at this point. So everything is coming from a flat file except for one field. Then I'm adding age, job, marital status, education, whether or not person is default, average balance, housing loan, etc., etc. You can see it's a fairly straightforward syntax. You could see how one column is added, and then you simply keep adding columns to it, whatever the columns you decide to throw into your model. If you want to modify your model later and just get rid of a column, just get rid of a line, delete it, and that's it. That column is no longer being used. And it's fairly straightforward. The next part is from. So we have to tell the system after we're done listing the columns is where to grab these columns. So I'm using everything from C and DT. So what's a DT and what's a C? So first from ACDM bank demo client, that's my main primary section table. So that's where all the information is stored. And I gave it an alias, I gave it a name called C. And then I'm saying that for some lookups, especially for those that I'm predicting the value on, I need to know some additional stuff. So I'm linking inner join. I'm inner joining another table, DT, and I'm grabbing basically, I'm connecting them by ID. That's all I need to do. And very straightforward select query. Then in this section, I have to define what my parameters are. So it's a JSON format, and you could see that it breaks down into two nodes. So the first one is going to be the input, and the second one is going to be output. On the input, I have to define every single field and describe it. So imagine like you're describing your MP3 files, right? And you're saying the artist, album, picture, whatever. It's doing essentially the same thing. You could see that the name prefers by alias. So there's my alias, age. I'm saying that the name is a type numeric. The job is the type lookup. Now, what's a type lookup? Type lookup simply tells the model that don't look at the absolute value of the thing. It's not going to be useful, but rather look at the fact that it's a discrete kind of a parameter. So, for example, you can have like our job description, right? So the job description, you could be admin, you could be blue collar, you could be thing of that nature. So it doesn't really matter what value I'm throwing in there, as long as it's a set value. It's kind of a class, right? So it's a classified value. Hopefully I'll be able to show that a little bit later and make a better explanation of what it is. The types of values we can have here: Boolean, numeric, text, lookups. So those are your main values. So everything is pretty much either lookup or numeric. And all I'm doing here is I'm saying education, and it's a lookup. Is required true? That basically whether or not this field is going to be required to make a prediction. So I said, sure, make it a true for pretty much everything. And I go through my list of fields, and I'm describing every single field. So it's a little tedious, but that's okay. It's easy. It's very easy to do. Every field follows a format. It goes into these curly braces, and it has to have at least two parameters: the name and the type. So the name is going to be either alias that I gave here, or if I didn't give the alias, then I would just simply refer to it by the name from the table. So if I said no name, just like that, then I would have to rename, describe it as this. It would be essentially the same thing. I keep going through this thing and describe and describe and describe it, and then that's it. Now what I'm getting to is I'm getting to my output column. Now I want to describe my output column. ACDM desired target list or lookup ID. That's where do I get the lookup from? So what's my what my result should be. And then I'm telling the model that it should be coming from this lookup, and it's a type of lookup, and that's simply a displayed name, but I don't really have to provide that value at all. That's all I have to do here. If that's not clear, we can do, well, you have to kind of try it once at least, see if you get an error. And then if it still doesn't make sense, maybe shoot me an email. I'll try to help you out as much as I can. Once you configure your model, you can go under actions and you can say train my model. When you train your model, nothing really happens here. So what you would need to do is go to train my model and say it again. It's going to give us a status. It says current session state, data transferring. Depending on the size of your data, like I said, we can have up to 75,000 records. So in this case, I am not restricting my data. I'm just transferring absolutely everything. I'm not saying go and take only 75,000 records. It's going to take pretty much everything I got in the system, 45,000 records or so. It's then submitting it to the server, and the server is going to try to train. So if we go to train the model again, it's going to tell us training. And then eventually it's going to come back to us and it's going to say, I am done. Now, every time we train the model, and still training, every time we train the model, it's going to have a new model instance of some sort, and we kind of keep the history, but you can't get access to it. So you're always going to be using the latest model. However, if something happened or in the future releases, you will be able to default back onto a new release. So today, if you want to use different training models, then basically create, copy, paste everything, exclude a couple of fields, go and train. That's going to be your new model with new parameters. Okay. When the model is done training, you'll see results in your history tab, and the history tab will tell us what the current status of the model, whether or not it's successful, whether or not it's being used. Now, prediction enabled, this checkbox will tell us whether or not we can actually use this model. All right. So while we're going through training of 45,000 records, let's review how we can actually use the training, use the already trained model. So in order to do that, we have to use a couple of elements that are described in the business process. Now, if you've never built business process, then welcome to administration training, and you'll be taught. But if you know what it is, just go into a business process. And in business process, we have couple of processes already that use or utilize this machine learning. So you can find them. For example, score qualified lead. You can open this process and you can see how it's done and what it's doing. And this is where you can probably have the best idea how to implement it on your own. Now I'm going to show you from scratch, but nonetheless, what this thing is doing, it's got a signal, and it's basically saying every time something changes in the lead, so you could see that lead change is changing and the lead stage is equal to nurturing, run this sub-process, and this sub-process happens to be lead score. If we open this one, it will actually tell us how to score the lead. To score the lead, it's fairly straightforward. However, there's two ways. There is an easy way, and there is a very easy way. The regular way that you can find here is by using this user task. So you just grab it on your design surface, user task, and you find ML entity prediction. And then we have to pass the value of the model that we're going to be using, and we have to pass the value of the record ID. I'll show you how we can do it. So it's a 2-element or even 1-element business process. So I've pre-configured a business process to train in our model, and I called it bank deposit demo. Let's open this guy. Now, in my case, I had to design this process so that it could use both scoring and classifying models. So that's why you're seeing that 2 scoring models are being used at the same time in parallel. I'm using the and parallel execution. I also use 2 starting condition, either on record edit or record modified. I am then storing the record of the starting condition into a variable that I defined as the process parameter, called it record ID. I link the element to the audit log by using connect object to record or connect process to object element. And then I'm starting 2 elements. The first element is going to be ML entity prediction type of a user task. I am defining the model that I want to use. So there, just by simply clicking on the, by simply choosing a lookup value, I can look up all the models that are currently available, and there's a list of models. So I'm going to be using this one to do the classification and this one to do the scoring. And then the second element that the user task is requiring is the record ID, and I've already stored it. Now, classification is exactly the same thing. There's absolutely no difference with the classification other than I am simply telling the model to use a slightly different model. So here we classify and here we score, and you can see that I'm using different model. That's all it is. So now let's see how this thing works. Let's go to our ML bank demo, and this record is already not record. This section I played around a little bit, so you may see some weird data. But let's open the one that I haven't touched. Now, when we have a classification model, the first thing that we're going to see is that the field that we're trying to predict, it's got this little cloud. If you click on the cloud, the system is going to tell us that we have a value yes. So first of all, before we even click on the cloud, so you could see that the desired target is yes. Now, why is it yes? Because the system went through the model and looked at the data that we've submitted right here, and it figured that there's a 96% chance that the answer is going to be yes. It is significant enough to make a solid prediction, so it actually filled the value for us. Now, the classification problem is slightly different algorithm than, let's say, scoring model. Scoring will always return us numeric value, telling us the probability of the outcome, whereas the classification only going to fill the value in the desired field if the result is significant. So for example, if it's a 50-50 chance, we're not going to be putting any value here. We're simply going to give you yes 50, no 50, and then you have to, as the user, decide which one you go with. So in this particular case, or in that particular case, we would make the prediction. When the cloud basically appears when we design a classification model and say to predict. So once we enable that option, the cloud will appear automatically. We don't really need to do anything. So let's go ahead and change, for example, some data here. I'll remove the pre-classified value, and I'm going to say that the average balance the person is carrying is, let's say, $5. Education, let's say only primary. Let's say the person is divorced, and it's going to be unemployed. And basically, duration of my last conversation is I'm going to do 30 seconds. So it's probably not going to be a very good, lead for us, right? So let's open this thing, and there you go. You could see that the value has been updated to no, and I can click on my cloud, and it will give me a probability of each output. So it's telling me that no, 98% is that the person is not going to buy term deposit based on my experience of the observed data, and 2% that the person is going to buy. So maybe he or she got inheritance of some sort, so really wants to buy it. So again, we're going to make a prediction when the split is significant enough. That's pretty much how the system works. If the value is already there and we're using this user task that I just showed you in the business process, we will not be rewriting a value in this field once it's updated. So for example, I can go back and I can change everything to where it was. So it was 400 seconds here, and instead of $5, let's say give him a little more, and the education this way, and let's say married or single, whatever it was, and let's say it's going to be, I don't know, some sort of a job. So let's say management, right? So sounds like a good case for us. The value, once it's selected here, will not be recalculated. If you want to recalculate the value, you have to implement this prediction model in a slightly different way. Slightly different ways by using your script task, for which there is an article in the Academy, and I will share all that information with you a little bit later at the end. It's a little bit more difficult to implement, not just as one element. You actually have to write a bit of your code, but nonetheless, you'll be able to specify whether or not you want this value to be overwritten or not. By default, we're not overwriting anything once it's been selected and calculated. All right. The next type of model, let me go back into my models and let me deactivate this one. I'm going to deactivate this model, and I'm going to activate my scoring model. It's the same thing. Now let's go through the training query. The training query, as you could imagine, it's exactly the same thing. There's absolutely no difference in how I train the model. So it's simply copy-paste from one model to another. This guy is also exactly the same, except for one field. This little blob of information says transformations. And what it's doing, it's basically telling me that I need to select one-off. And when we're doing prediction, it's always one-off, and we have to provide the idea of that one-off. There is a great explanation on the article. For now, all I'm doing is I'm just simply asking a question. Give me a probability that the person is going to buy this term deposit or subscribe to term deposit. So I'm providing here the ID of my yes record. You can go in the lookup and look up the ID. In my case, I have a local access to my database, so it was easy for me to look it up. The next thing we need to do is simply define how many times we would like the thing to train. So we're saying every 30 days, and the quality, again, we're expecting no less than 80%. Now there is this step number 3, and for simple models, when we are trying to score individual records, not kind of a batch thing, then what you want to do is you want to simply copy this whole thing and paste it here. There's really no other way to put it. You just simply copy paste. What this element is going to do is a prediction query when we're trying to, let's say, update every night a lead or some other record that we have the prediction model configured for new data. And so, for example, every night you're getting a lead and you want to send it to a machine learning server and you want to get the new values. In order for us to know what's considered to be new values, which we would like to train, we need to have some sort of a query. So, for example, the query can say, show me all the records that were created today. That's good enough. All we would need to do is we would need to add a new clause to our select query and say where, and then express the condition of this where. So, for example, where column, in our case, it's a column C dot, not dot, but maybe a comma, and then the value is going to be created on. I believe that's the column name, and dot is equal, and then etc. etc. And what is it equal, or it's greater than, or whatever the where clause is. So if you're familiar with SQL, it's not going to be a big deal for you to figure out how to write it. Especially if you review the already existing model, every demo stand comes with few pre-configured models from which you can learn the syntax of some of the more complicated queries. Once this is done, the model is now activated. I have previously trained it, so rather than sitting here and training it, you could see that I've trained this already on 45,000 records and 4,000 records just to kind of see what my prediction or what my expected accuracy and how it's going to change. And in all fairness, it hasn't changed by a heck of a lot. So 4,000 records or 45,000 records, I have not seen much of an improvement in this value. So just be careful with the amount of data that you're shooting into the server. Now let's see how that works. No, I'm not going to say anything. Now let's go into this model. So currently the probability is 63%. Let's change a few things. Let's say that your age is going to be, let's say, 15. And again, you're going to be divorced. You're not going to have any money in the bank account, so let's give you 80 bucks. Mobile phone is going to be the contact. Let's say you've been in default. Duration doesn't really matter. So let's say that we want to predict. We remember it used to be 63%. Let's close this. Now, if you're familiar with how business processes are executed, you know it's the server-side logic, which means that we can't really send a message onto the front end and on what we're seeing. So we have to close the page and reopen it again. So let's open it again. And there, it's giving me a probability of 60%. So for some reason, the machine is thinking that I have 60% of the outcome. So it used to be 63, now it's 60. Now I can't really tell you at this point, I don't have metrics to tell you what's the significant thing here, why it was 60% versus 65%, what changed. I don't really know that yet. In the new releases, I might be able to show you maybe in the version 2.0 of this webinar what's coming down the pipeline that you will be you'll be able to easily identify the significant features and the ones that affect your prediction outcome by the most. But at this point, unfortunately, I can't. So then when I get my probability of the yes, I have to decide, is it a strong yes, is it a weak yes? Like, what should I do? So 60% probability doesn't really tell me if it's a yes or no. Now I have to make, as the person, I have to make a decision. So for example, I can make a decision and I can say, if it's greater than 50%, then it's a yes. If it's under 50%, that it's a no. But that's probably not a very good outcome. Maybe you want to say then, if it's greater than 75%, then it's a yes. Everything under 75%, it's a definite no, or just simply a no. So you want to classify it somehow. If you're familiar with the lead scoring, you may notice that here in this container, in this section, we have an element with 3 stars. And that element, for example, is scoring the probability of converting a lead from where it is now to a successful sale. And we're classifying it based on the probability, and we're giving you 3 stars. So for example, 1 star, 2 star, 3 star. So if it's a 3 star, then we're pretty confident that we're going to be successfully converting it. If it's just 1 star, we think we're going to convert it, but we are not 100% there, right? So you have to come up with your own brackets. Now, once this value is created, it's no different than the user coming in here and doing it by hand, which means that you can launch various business processes that do some logic, or you can use it in some other elements. So what kind of other elements? Let's assume that this whole information you're getting from some sort of a landing page. If all this stuff is coming to you from a landing page and you want to call people who you are more confident that the sale is going to convert, or in our case, that they are going to sign up to our term deposit, then you probably want to go into your service, configure action, or what is it, agent desktop, configure a queue in such a way that, let's say, somebody with a probability of 75 and greater, I want to put them on the top list and I want to call them. And that's essentially going to be your call center. Maybe that's how you want to operate your business. Or maybe this answer is going to give you something else. Maybe you're predicting some sort of a fraudulent activity or suspicious transactions or whatever the case might be. So the idea here is that we can predict the value based on the observable experience expressed in the features that we select for our data. This is essentially what it is. Now the process right now in my version, I have to turn off one model and then turn on the other model. So I shouldn't be using two at the same time. It's not how we foreseen this implementation, but there's nothing stopping you from using two at the same time or three models at the same time. Now, like I said, we can have 3 or 4 different models trained on the same data set, just you choosing features a little bit differently, and you can play around and see which one works best for you. But this is essentially how the prediction works, how we can use the machine learning. You can use it on any data, so the volume of data is definitely important, and then the complexity of your features. Like I said, if it's a drop-down lookup list of 50 possible values, then just bear in mind that you need a lot more information to train and to find correlation between the input and the output. So that's going to be very, very important. Now, in the new version, you're going to have a bunch of tabs here. These tabs are going to show us very important metrics, such as correlation between the features, whether or not features are important, the coverage of the feature, so that means how many times in my data set the feature is actually present or it's missing. So all that stuff is going to be coming in the new releases. I'll try to show you maybe even pre-production release. I can't do it now. The other thing to bear in mind is that you can train this model to, or train any machine learning model right now, especially classification, to work with text. So let's assume that you're getting an email and you want to classify that text into angry email, happy email. Let's say you have a binary classification, or maybe you want to use that email to classify the cases that you're opening from emails. So what you would need to do is you would need to grab the probably the subject of the email, the body of the email, maybe some other characteristics such as IP addresses from where it's coming, or the country where it's coming, or some other metadata describing this thing, and then throw it into the machine learning, and then we will try to classify it for you. Again, like, we're not going to classify it based on nothing. We have to have history. So if you have a couple of good records, a couple of thousand good records, then we can do a really, really good job on text. So we can classify text, especially if there's like 5 or 6 different possible values to choose from. So that's really it works really, really well. So that's it. That's all I wanted to show you for today's model. For how to use it. If you have any questions, feel free now. Otherwise, I'm done with how to do it. I will save all this information. I will save all the input data. I'll save all the sections, and even maybe create a package for you so you can just simply download it and install it into your own demo stand, so you can see how it's done. If you have any questions, feel free, or just follow up with an email. Let me know what you would like to see us do maybe in the future. If you have a data set or a particular type of problem you don't know how to approach, and just shoot me an email, and I'll have great internal resources who can help me out pretty much use any of that stuff. So again, thank you for coming, and at this point I think that I'm done with the webinar. Thank you.